Good morning, everyone. My name is Saanika Kulkarni, and I'm a high school junior. And today I'll be presenting on mapping visual comfort for energy efficiency and sustainability. So last summer, I had the opportunity to work at Princeton University as a high school summer research intern. My lab team's focus was on improving thermal comfort for the occupants in a room and on developing the smart sensor, which essentially takes the longitudinal and the azimuthal axes to make a map of space. And here's a picture for reference. In order to expand on the scope of the smart sensor, I decided to independently research visual comfort, which is another axis of monitoring indoor ecosystems along with thermal and audio. Visual comfort essentially defines the lighting conditions in a workspace and depends on factors like the level of light and the color temperature. Lighting affects work performance, the level of alertness, and also impacts energy usage in commercial and residential buildings. My primary engineering goals were to essentially optimize the smart sensor in order to account for the lighting architecture in a room and create data visualization models to calculate and to map the visual comfort metrics. Speaking of metrics, out of all of these photometric units, I decided to go with illuminance, which is essentially the amount of light that hits the surface. And essentially, since this is vital to human perception, I thought this unit was the most relevant for my particular engineering project. In order to measure the RGB light intensity and the illuminance, I used two low-cost sensors, and then I connected them to my Arduino. And this is a part of my prototyping stage. I then integrated the Arduino with the smart sensor Raspberry Pi, which was essentially its backbone, and then programmed a Python script to push all of the outputted data onto an Excel file, which I was able to retrieve through my computer. In order to eliminate any confounds and get as many precise values as possible, I designed and 3D printed cones during my retesting and redesign process to narrow the angular field of view of the sensor, and here's a picture on the sensor. After collecting multiple data sets, a sample of which is shown here, and a data set actually consisted of more than 10,000 points. After collecting the data sets, I then proceeded on to clean up the data and to start creating models using RStudio, which is a popular data science platform. So here's the first data visualization model, which captures the illuminance. So there's a key. According to the key, all of the red values indicate the highest lux value, and therefore the brightest spots in the room. And then the darker spots indicate the dimmer spots in the room. So this conveyed the lighting architecture really well. In order to diversify the data sets that I collected, I also tested the smart sensor in different lighting environments. For example, this one compares a brightly lit room versus a dimly lit room. And in order to account for the color temperature, I also mapped the individual RGB values onto using RStudio. For example, if a light has a majority red appearance to it, then it tends to be warmer, and that basically conveys the color temperature. And this is something that I will be focusing on in the future. Future areas of improvement, I would like to alter the field of view of the cones, as I indicated earlier, and also use larger data sets. Although my data sets consist of 10,000 points, I would like to have additional data sets as well. And also, during the data cleaning process, I would like to minimize the amount of the data points that I lost using a hardware optimization and using alternative algorithms. In the future, I would also like to continue my, like I mentioned earlier, I would like to continue my research on the color temperature spectrum and also include additional lighting variables such as the geometry of windows or the photometry of surfaces, the amount of glazing, etc. I would also like to develop machine learning models, especially recommendation systems, similar to how we see on Amazon, Netflix, and YouTube, in terms of how they serve up recommendations based on your buying history or your viewing history. And essentially, I would like to use these machine learning models to tailor to an occupant's comfort level and tailor it to their needs, basically. In the future, I would also like to develop three-dimensional or volumetric visualizations using platforms such as MeshLab or Blender in order to get a dynamic view of visual comfort, and that will be very beneficial for a holistic view for all the lighting architects to plan lighting architecture better. All in all, my engineering project actually produced a successful outcome since all of the engineering goals were met. Since as smart home technology grows in popularity, mindful planning through the Visual Comfort Project will ensure occupant well-being and energy savings in the future. I would like to sincerely thank Professor Forrest Meggers, Nick, and Eric, as they were my entire C.H.A.O.S lab team at Princeton, as well as my parents. My mom's right there. So thanks, Mom. Thank you.
I'll start with the immediate question. I understand this is not my field in terms of the visual comfort notion.
Right.
So I'm curious, in using the illuminance as what you chose to focus on, and then you said you wanted to put those cones to narrow the angular view of the sensor. Could you say just a little bit more about why you chose to do that?
Yeah, sure, definitely. That's a great question, actually. So illuminance so there were multiple different photometric units, such as there was the luminance, which indicated the light source. But since as occupants, for example, we are in situations where the rooms are too bright or too dim, and it's not just the light, it's how we perceive the light. So that's what illuminance essentially quantifies. And so the lux value is like the unit, and the illuminance is like the overall photometric unit. And so I wanted to narrow the angular field of view, because in order to get a precise data point from a certain location or coordinate in the room, I need to have in order to funnel all the light in, I need to have the like a tunnel for it to pass through. And I can actually go back to the slide, for example. Yeah, so I had to design, this is like a cross section, and these are like ridges. So they essentially, as the light strikes, it basically bounces in and goes to the sensor. So there was a very intricately designed cone that I was able to put it on the sensor.
Okay. And the whole purpose was to then get a more
precise value, exactly. And they were black in color because the reflectivity index.
Right.
Yeah.
Thank you.
Yeah, thank you.
So it's very good. So I have a question for you. You did a great talk about data collection.
Absolutely.
Right?
Thank
but
you.
The key, because I'm in this business,
Uh-huh.
is how do you take data and turn it into knowledge,
That's
information?
great
So
question.
have you thought at all about how you have a ton of data,
Yeah.
and now you have to figure out how you turn that data into knowledge and information?
Yeah.
Have you thought about that part?
Yeah. So, like I said, I collected multiple different data sets, and so those are the axes, the home axes, and then the lux values, and then the RGB light intensity. So after I was able to plot the illuminance, or this specific graph, I was able to understand the lighting architecture. But then I had to go one step further as to what does the data mean exactly? Yeah, analysis. And so the whole experiment actually made me conscious of the fact that it's important to take multiple data sets in order to arrive at a conclusion. So, which is why I actually made the point that I wanted to diversify the data sets, and I tested the smart sensor, the visual comfort sensor, into multiple different lighting environments in order to come at a conclusion. And I was also able I didn't want to waste all of the RGB data, so I wanted to build upon the color temperature, because there were a lot of neat precedents out there, and I wanted to build upon that data. And speaking of data science, it's really important to read up all of the precedents and then see how much research has already been done on that color temperature aspect. And I think that the data sets that I collected actually just reinforced my knowledge of the lighting conditions and lighting architecture. So this was really a very gratifying process in terms of collecting all the data, plotting it, and collecting more data to verify and validate the solutions. Yeah, thank you.
It is. It's a tremendous amount of data.
Yeah.
But translating that into experience.
Mm-hmm.
I mean, is there any way that you quantify how you translate all of that terrific data into this room?
Mm-hmm.
Like in terms of whether it's pleasing or comfortable or, you know, you've got a great deal of data about what's in the room.
Right.
But how do you translate it into an experience in terms of this is enough light?
Yeah.
This isn't enough light. I don't feel comfortable in this room. I do feel comfortable.
Yeah, great question. So since like lighting is subjective, sometimes some people prefer having brighter environments and some people just prefer having dimmer environments. However, scientists have done a lot of research regarding this, like the light science, and there's actually, for example, it depends on which type of room you're in. And for example, if you are a doctor who is in a surgery room, you need a lux level of 5,000. But if you're in a dark area where you don't need as much light, then the lux level is a lot lower. So, and which is why actually in the future I would also like to build like machine learning models or recommendation systems in order to reinforce and then serve up recommendations as to what do you like what is comfortable for you, and then tailor that, and then have like a feedback loop that basically tells the model to adapt to the comfort level of the occupants. Yeah. Thank you so much.